Hello everyone, welcome to the Algebra 2 Unit 2 review. We're going to go ahead and bang this first page out real quick. So this first function, if you put it in your graphing calculator, is going to look like this, P, and that is a rational function W. Now the way you find the table of values is that you plug in the x into the function, see if you get the corresponding y. So 1, if I plug in, say, this function, 1 divided by 0 does not equal 1. We're not allowed to divide by 0. 1 divided by 0 is undefined. So it's going to have to either be this one or this one. So I'll try them both. 1 divided by 1, though, is 1, not 0, so it's not this function. So we'll save that for later. It has to be function in the table G. Now, this has a crazy asymptotes in it, so the domain is all values but 0, and the range is all values but 0. And the way we write that is right here in BB. For number 2, that is going to be the quadratic. And the table of values, once again, is I'm going to plug in, if I plug in 0 squared is 0, so it's not A. 4 squared is not 2, so it's not B. 4 squared is not 4, so it's not that, it's not C. We keep trying until we find one that works, and it turns out the one that works is I. Now, if we look at this function down here, R, the domain, we can put in anything we want, but we only get out positive values when we square something, so that'll be GG. The next one is a linear function, so that'll be LT. This is basically y equals x, so whatever I put in is what I get out, so that'll be C. Sorry for the beeping. And there are no restrictions on the domain or the range, so it's II. I'm just going to show you the rest of these. This is ANS, HH, the square, because that's a logarithmic function. This number 5 is the square root function, so I can't put in negative values. I'm sorry, number 5 is the square root function, so I can't put in negative values, so that'll be BQY. The square root function and that is CC. Number 6 is the absolute value function. That's going to be DOZGG. Notice that that is the same as number 2. This one is the greatest integer function, which is the step function. So this will be HM AA, and then the output is only has integers, so it's DD. This is FTXEE, and this is KEVWW. Now, a word about how you graph a function like number 9 is what you're going to want to do is bring up a graphing calculator. Turn it on. Wake up. There we go. And let's reset it so someone was reusing it for something else. So if I wanted to graph that, I would go to Math. If I go down, you'll see log base. And when I bring that up, it's like that. It's like number 9, but with the little 2 there. And I just do x. And I can graph. But I can also get my table of values to match my function. So for any of these, if you get stuck, you can always graph it and look at the table of values. Let's move on to the next function. So here, this is the same thing. I can graph this and get my table of values. Y equals the square root of x plus 2. And right away, I know that my graph is going to look kind of like that. And here are my table of values. Zero, 2, 1, 3, 4, 4. Those are all the ones I need. 0, 2, 1, 3, 4, 4. Hope if I could plot the points correctly, wouldn't it? And what we will see is that square root function like that. The domain, remember our Peter Parker, he can only walk underneath the function. So he starts at 0. He starts at 0, but 0 is included, and he walks to infinity. Or if you want it in set builder notation, the domain is all values of x such that x is greater than or equal to 0. The domain, that's the domain. The range is, once again, we take Peter Parker, we flip him into Spider-Man, and he has to start walking at 2. So that's 2 to infinity, or all values of y such that y is greater than or equal to 2. All right, so this function is, if we've been paying attention in class, is an absolute value function. But the plus 1 is going to shift the origin up 1, and the plus 2 is going to shift it to the left 2. And the negative means that instead of opening up, it will open down. This is the same thing you would see if you created your table of values. Now, when you go to your calculator to look at your table of values, I'll show you how to do that in your calculator. You want to make sure you have points that are on your graph and that show you the shape of the graph. So you always want to look at the graph first. Negative, math, number, absolute value, x plus 2 plus 1. So I know my graph's going to kind of look like that. Now this doesn't look exactly right because I didn't zoom square. Once I zoom square, now I get my graph. So when I get my table of values, I want to use the points that are actually on my graph, like -3, 0, -2, 1, -1, 0, 0, -1, 1, -2. And you will see that all of those points are on there. So the domain is all real numbers. So -infinity to infinity, or in set builder notation, all values of x such that x is a member of the real numbers. The range, though, is -infinity up to 1. Remember, we're talking about y values here. Square value because it's all values of y such that y is less than or equal to 1. Okay, oh, sorry, there was a mistake on the review. Number 5 and 6 were not covered in this unit. We'll deal with that later. That was So over what values is the function increasing? So if we do our roller coaster here, as we go left to right, when is the roller coaster going up? And it's from here to here. But the function asks for values of x. So it is increasing from -2 to 2. Here the roller coaster is going down, and here the roller coaster is going down. So it's decreasing from -infinity to -2 and from 2 to infinity. And we have two different groupings like that. We use the union symbol to unite them. Okay, so circle the letters of the function now. F of x equals that. So this is going to be a quadratic that's been shifted down 4. So any function that has a similar shape but has been shifted down 4 will be, or any function that has this same domain. So for E here, if I were to graph that, that would look like that, but it's still starting at -4. C, if I were to graph it, would start at -4. B is out because if I were to graph it, it's not shifted up or down, it's shifted to the right 4. I'm sorry, I hit the wrong button there. This one is out because if I graph it, it is shifted down not 4 but 5. This one's tough. This one you're going to have to graph and look at the graph. If we look at the graph, y equals x squared, x squared. Let's try that again. X squared plus 2x minus 3. If we look at the graph, what you can see is that the vertex is actually at -4. So these 3 are the right answers. Okay, for these, this is the green function here is the primary function. So they're asking what happens to the function as I shift up or down. So for this one, the -1 outside is going to shift all the points down 1. Sorry, my smartboard's a little bit off. This one is going to shift all the points to the right 3. On this one, the negative inside is going to reflect everything along the, everything's reflected along the x-axis. Here the negative's outside, so everything will be reflected along the y-axis. Okay, so here are the composite functions, which we did in our review last class. So first off, g of 4 would be 3 times 4 minus 6, which is 6. So really this function is asking for f of 6, which is 6 squared plus 4 times 6, or 60. So that is f of g of 4. For this next one, it's asking you to create the composite function. So that's 3 times whatever I'm plugging in minus 6, and what I'm plugging in is the whole other function. So it'll be 3x, I'm sorry, that's a little confusing. That'll be 3x squared plus 12x minus 6. Sorry, now it's my...
Please report to the main office. Ms. Grimes, please report to the main office.
So for this last one, this symbol means inverse. So what it's asking you to do is to switch x and y. And then you got to solve for y. So I would add 6 to both sides. I'd get x plus 6 equals 3y. Divide both sides by 3. And get 1/3 x plus 2 equals y. So the inverse of x is 1/3 x plus 2. So now, before I was giving you the equation, I wanted the graph. Now I'm giving you the graph and I want the equation. So first of all, you would look and say, hey, this is a parabola. That means this is a quadratic. And the general form of a quadratic is y equals x squared. But if I have y equals x squared, the vertex is supposed to be at 0. And it's supposed to open up. This function's not doing that, so why not? Well, what's happened is that the vertex has been shifted to the right 2. Remember, stuff inside goes backwards. And it's not opening up, it's opening down. For this one, we'd go, ooh, that's a square root. Which is this. But a proper square root function opens this way. That function's not doing that. So how do we need to change it? Well, it's been reflected, but not vertically, but horizontally. So the negative is not outside the function, it's inside. All right. And our last problem here is to sketch the inverse. Now, remember that inverses are symmetrical on the line y equals x. But another cool inverse trick is to pick some points. So this is 3, 0. This is 2, 1. This is negative 1, 2. And this is negative 6, 3. Remember, the inverses switch the x and the y. So I will need 3, negative 6. 2, negative 1. 1, 2. And 0, 3. And there's my inverse. And if I were to drag that over, you would see, sure enough, it is the reflection. Okay? So that's it. If you have any questions, please be ready with them in the first couple minutes of class. And good luck on the test.